So welcome to section 7.3 on double and half angle formulas. Your essential questions for today are, how do we use the double angle and half angle formulas to get the exact values of trig functions? And how do we use these formulas to help us verify or prove identities? So basically the essential questions are the same two essential questions as our 7.2. Um, Um, but I just, but we're just talking about different types of formulas, okay, which are double and half angle formulas. So essentially, the mindset is the same, right? We're still gonna think of a way to get the angle, not by adding or subtracting, but by dividing it by 2 or multiplying it by 2. So here are the formulas. The double angle formulas are these guys here, okay? So it's essentially 2 times the angle x, all right? And you have it in front of you as well, but I wanted to show you guys this up here. And these are the half angle formulas. And the choice of plus or minus on these two, it depends on the quadrant which the half angle lies. Okay, so let's say you get the sine of the half angle formula, right? And if the half angle, if it lies in quadrants 1 and 2 for sine, it'll be positive. If it lies in quadrants 3 or 4, it would be negative. For cosine, if it lies in quadrants 1 and 4, it will be positive. If it lies in 2 and 3, it would be negative. Okay, so these are all the formulas here. All right, so let's run through some examples and then we'll refer to our formula sheet to help us out. Okay. So use the appropriate half angle formula to find the exact value of the expression. Okay, so sine of 15, I'm going to quickly just do this because here, honestly, with these three, you can use any formula you want, right? When we're doing this, yes, it says use the appropriate half angle formula. I only put this up as an example is because we want to practice using the half angle formula, okay? But when it comes down to it, you can use whatever you want. So 15 can be 45 minus 30 and use the subtraction formula for sine, right? But here, for the sake of practicing our half angle formula, I'm going to go sine of 30 divided by 2, right? 30 divided by 2 is 15, so we're good with that. The sine half angle formula is sine of x over 2 equals plus or minus the square root of 1 minus cosine of x over 2. Okay? So if I plug in cosine of 30 into here, or sine of 30 divided by 2 equals plus or minus square root of 1 minus cosine of 30 over 2. We know what the cosine of 30 is. Cosine of 30 is rad 3 over 2, all over 2, correct? Now, is it the plus or is it the minus? It depends on where 15 degrees is, right? 15 degrees is in my first quadrant. So this would be the positive version of this whole thing. 1 minus square root of 3 over 2 over 2. And if we simplify this out, right, I'm going to multiply everything by a 2 over 2 first. Why am I multiplying by a 2 over 2? That would essentially get rid of this denominator, both denominators. Okay? So if I multiply by 2 over 2, positive square root of 2 minus square root of 3 over 2. And this square root should just be in my numerator now. Right? Because 2 square root of 2, 2 times 2 is 4, square root of 4 is 2. Okay? So here we have square root of 2 minus square root of 3 over 2. Okay? And that's my answer. All right? 5 pi over 12. Remember, we're going to turn that into degrees. So what is 5 pi over 12? In terms of degrees? 75. Okay? 5 times 180 divided by 12, that's 75. Okay? So remember all the angles that we listed out in our previous, in 2 lessons ago, right? The ones that we do know. We know 150 degrees. Divided by 2 is 75. Okay, we know the tangent of 150. We know all the trig functions of 150 because that would be a 30-degree angle in my second quadrant. Okay? So then if I use the tangent formula for half angle, that would be, I'm going to use the 1 minus cosine. 1 minus cosine of 150 over sine of 150. Okay, that's the tangent of 150 divided by 2. Okay? So what is the cosine and the sine of 150? Well, like I said, that's the 30-degree angle in my second quadrant, right? 30, 60, 90. And then 1, square root of 3 and 2, but this one's negative because I'm in my negative x-axis. And tangent's going to be square root of, or 1 over square root of 3, right? The tangent of this angle equals negative square root of 3 over 3. But I need the cosine and the sine. Oops. So the cosine of this angle is 1/2. And the sine of this angle is, no, the sine of this angle is 1/2, opposite over hypotenuse, or y over r. And the cosine of this angle equals negative square root of 3 over 2. So if I plug in those values into here, that would be 1 minus negative square root of 3 over 2 over 1/2. So this is 1 plus square root of 3 over 2 times 2, right? Multiplying by the reciprocal just to clean this up. Distributing out the 2, this would be 2 plus square root of 3. Yeah, 2 times 1 is 2. 2 times square root of 3 over 2 is square root of 3. Okay? Cosine of 165. (165) would be the cosine divided by 2. What number? That would be 330? 330 divided by 2 equals 165? Yeah. So the cosine formula, you can look at your formula sheet. It's plus or minus the square root of 1 plus cosine of u, which is 1 plus cosine of 330 over 2. So 330 is in my fourth quadrant, the 30-degree angle here, right? So that's square root of 3, that's 1, that's 2, that's negative. So cosine would be square root of 3 over 2. So plugging that in, 1 plus square root of 3 over 2 over 2. And again, I'm going to be multiplying both top and bottom by 2. So then we get 2 plus square root of 3, big square root over 2. Is it the positive or the negative version though? 165, right? Where is 165 degrees? In my second quadrant? Square root of 4, which is 2. I did.
By 2 is 4, but then you square root it, which comes out as square root, and it just continues again.
Yeah. What she said. So the reason why my denominator is 2 is because I multiplied it by 2 over 2, but 2 times 2 is 4. Square root of 4 is 2. And then everything else I just multiplied. 1 times 2 is 2. Square root of 3 over 2 times 2 is the square root of 3. Okay? So 165 degrees is in my second quadrant, where the cosine of that number would be negative. That's why it's negative this value. Okay? So that's how you would use the half angle formula. Okay? But again, you can use the addition and subtraction formulas as well, if that's simpler for you. Okay? All right. So here, if cosine of x equals negative square or negative 2 over 3, and x is in quadrant 2, find cosine of 2x and sine of 2x. Okay, so I'm going to put down the sine formula for 2x first, which is 2 sine of x times cosine of x. Okay, so I need the sine of x, right? I know cosine of x is 2/3 negative 2/3. And I know x is in quadrant 2. So what I'm going to do is just draw a random triangle in quadrant 2, right? Cosine, which is x over r, is 2 and 3, but that's negative. Using the Pythagorean theorem, I know this side here is square root of 9 minus 4, 5. Yeah, use the Pythagorean theorem to figure out that side. Okay? So my sine of x is equal to square root of 5 over 3. All right? And so if I try to get sine of 2x, that's just going to be 2 times square root of 5 over 3 times negative 2 over 3, which is negative 4 square root of 5 over 9. And you're done with sine of 2x. Okay? For cosine of 2x, I'll show you the formula sheet. Here we have three basically of the same thing, right? They're all equal to cosine of 2x. Okay? What I like to do, class, since my sine and cosine, they're both over 3, I am just going to use the first one. Because this, well, let me show you. Why? Cosine, I'm going to use cosine squared x minus sine squared x. Okay, cosine squared x would just be cosine of x squared minus sine of x squared. Cosine is negative 2/3. Sine is square root of 5 over 3. So that would be positive 4 over 9 minus 5 over 9, which is 1 over 9, negative 1/9. Okay, the reason why I use this is because it creates the same denominator already. Okay, so you think you're doing more math because by squaring it, you're actually doing more manageable math. Yeah, it doesn't matter which one you use, honestly. Okay, using the other two on the bottom, you would have to get the common denominator and do it that way. Okay? All right. Cool. Now this one here, it tells us cosine of 2 theta, find cosine of 2 theta. If you're given that sine of theta is negative 3/5 in the third quadrant, right? So I'm going to draw a triangle again. Negative 3 over 5. So that's negative 3. That's 5. Using the Pythagorean theorem, 6, that's 4. Right? That's a negative because I'm in my negative x-axis. Questions on that? So sine is negative 3/5 and cosine of theta equals negative 4/5. Right? Using that, I'm going to use a different formula for the double angle formula for cosine. I'm going to use 2 cosine squared x minus 1. Okay, so 2 times negative 4 over 5 squared minus 1. That's 2 times 16 over 25 minus 1. That is 32 over 25 minus 1. 32 over 25, or 1 is 25 over 25. So 32 minus 25 is 7 over 25, right?
-4.
Oh, this should just be theta. Yeah. X, theta, they're just variables. Yeah. So that's why I like the other one better. Cosine squared of theta minus sine squared theta equals cosine of 2 theta. Because if you do this math, right, this would be negative 4 over 5 squared minus negative 3 over 5 squared, right? If you square that, that's 16 over 25 minus 9 over 25, which you would get 7 over 25, right? You get the same answer anyway, but this one just requires you to do a little bit more. Okay, so it doesn't matter which one you use, you'll get down to the same thing anyhow. Okay? Right on. Questions on that? No? We're just using the same, or we're using the different formulas to find everything that we need to find, right? So we're gonna find the half angle for sine, cosine, and tangent from this given information. What does this tell us? If x is between 0 and 90, it's in the first quadrant, right? So they could just tell us it's in quadrant 1. Same thing. Okay? So if it's in quadrant 1, I'm gonna go ahead and draw out a random triangle in quadrant 1. Sine is 3 over 5, so that's my x. Sine is 3/5, so this is 3, that's 5. To use the Pythagorean theorem or know the Pythagorean triplets, it's a 3, 4, 5 triangle, so that's a 4. Okay? So the sine of the half angle, I want to put x over 2, equals plus or minus the square root of 1 minus cosine of x over 2, right? So to get the sine, it's going to be a plus or a minus. This is my x. Plus, right? Yeah. Even though if you half it, it will still be, even if you half this angle, because I'm getting the half angle, right, of x, it will still be in my first quadrant. Okay? So this is a plus square root of 1 minus, what is cosine? 4/5? Yeah. 4 over 5 over 2. So then this would be the square root of 1 minus 4/5, that's 1/5 over 2, which would just be square root of 1 over 10, right? So we have to rationalize the denominator. That's 1 over square root of 10. If you simplify that, so this would be square root of 10 over 10. Okay? Make sense? Doing that math class And looking at these two half angle formulas, the only difference between sine and cosine is that plus or the minus, right? Yeah. So I'm not gonna rewrite all of this. I'm just gonna say that the cosine half angle formula is just gonna be plus, because I already know it's a plus, square root of 1 plus 4/5 over 2, right? So 1 plus 4/5, that would be 9/5 over 2, which is square root of 9 over 10, which is 3 over square root of 10. So that's 3 square root of 10 over 10. Okay, doing this math pretty fast because we've already had practice with all of the radicals and whatnot. Okay? You gotta find a tangent, right? Hmm? Multiply both top and bottom by square root of 10. So rationalizing the denominator, square root of 10 times square root of 10. Square root of 10 times square root of 10 is just 10, right? If you want to think about it, square root of 10 times square root of 10, that's square root of 100, which is 10. And then 1 times square root of 10 is 10. Yeah. Okay. So if we wanted to get the half angle for tangent, there's one of two things we can do. We can first, we can use any one of these formulas, or what else can we do? What else could we do? What else could we do? Yeah, put it as sine over cosine. That's what I would do, honestly. Use sine over cosine, right? And just multiply them out or divide them, right? And honestly, class, I would use the unrationalized version of this. You can use the rationalized version. Actually, let's use the rationalized version because we already got it, right? Tangent of x over 2 equals sine of x over 2 over cosine of x over 2. Sine of x over 2, I'm going to put it in the back. Square root of 10 over 10, or divided by cosine of the half angle for cosine is square root of 3, or 3 square root of 10 over 10. Multiplying by its reciprocal. So square root of 10 over 10 times 10 over 3 square root of 10. So then these square root of 10s would cancel out. These 10s would cancel out, and you're just left with 1/3. Yeah, that would be 1, that would be 1, that would be 1, that would be 1. 1 times 1 is 1. 1 times 3 times 1 is 3. Cool? Questions on this? Okay, so all we're doing is we're just simplifying using these formulas. All right? So just like our previous lesson, I'm going to split these up into 2 lessons. So that is the first half of section 7.3, which is on double and half angle formulas.